session, we are still going to look at approximate methods. But in this one, we are going to look at examples. We are going to solve examples of our previous video. In the previous video, we proved the formulas. In this time around, we are going to solve examples for further understanding. So the first example we are going to take is that you use the first three successive approximation of the solution of the integral equation below. Y of s plus integral from 0 to 1 st y of t dt equal to s squared. The key word is successive approximation. This is successive approximation. That means that I'm going to use the approximate method using the free term. And first, this integral equation is a Fredholm integral equation because it's from 0 to what? 1. So let's start. Solution. Since the successive approximation, we said our phi naught of s is equal to f of s, and phi n of s is equal to integral from a to b k of st phi n minus 1 of t dt. And we said a series solution will be able to approximate the integral equation. That is y of s is equal to phi naught of s plus lambda phi 1 of s plus dot 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 plus lambda n phi n of s. Now let's take our integral equation, which is y of s plus integral from 0 to 1 st y of t dt, which is equal to s squared. Now let's make y of s a side of the equation. We're going to have y of s to be equal to this s squared minus integral 0 to 1 st y of t dt. Now we need to identify our free term. In this section, you can see that our free term f of s is equal to s squared. Now our kernel is st. K of st is s times t. Now the investigative parameter, which is the lambda, is minus 1. Minus 1. Now we can say that from this relation, phi naught of s is equal to what? F of s. Then we are going to say that phi naught of s should be equal to s squared. Now, by the method of successive approximation, I'm going to look for all the phi naught, phi 1, phi 2, phi 3, because they said the first three successive approximation. We need to look for phi naught, phi 1, phi 2, and phi 3. Now, our phi 1, y of s should be equal to integral from a to b k of st phi 1 phi naught of t dt, and our phi naught of s is equal to s squared. Now if we change the s to t, we are going to have phi 1 phi naught of t to be equal to t squared. Now you're having phi naught of t here, phi naught of t to here. Now let's substitute this phi naught of t into this equation. I'm going to have, and k of st is also giving us what? St. And the limit of integration is what? 0 to what? 1. I'm going to have our phi 1 of s to be equal to integral from 0 to 1 st times t squared, then dt, which is equal to integral from 0 to 1 s t cube t raised to the power 3 dt. So if we integrate this with respect to t, we're going to get s t raised to the power 4 divided by 4. Evaluating it from what? 0 to what? 1, which is the same as s over 4. That means my phi 1 of s is equal to s over 4. Now let's proceed to what? Phi 2. And in the phi 2, from the formula there, phi 2 is giving us, phi 2 of s is giving us integral of a to b k of st, then phi what? 1 of t we are saying that our phi 1 of s is equal to s over 4. This implies that phi, if we change the s to t, we are going to have our phi 1 of t to be equal to t over 4. Now we have phi 1 of t here, our k of k, the kernel k of st to here. Then you have to, in the limit is 0 from 0 to 1. You have to substitute everything into this relation. So we're going to have our phi 2 of s to be equal to the integral from 0 to 1. Then st times t, then dt. This is the same as integral from 0 to 1 st squared dt. So from this relation, we are going to have phi 2 of s to be equal to integral from 0 to 1, the kernel, which is given as st dot, then the phi 1 of t, which is the same as t over 4, then dt. This is the same as integral from 0 to 1 st squared over 4 dt. If you integrate this respect to t, you are going to get st raised to the power 3 divided by 3 times what? 4 will give me 12. Evaluated from what? 0 to 1. Wherever you see t, you replace it with what? 1 or 0. You're going to have this is the same as s over what? 12. This implies that my phi 2 of s is equal to s over 12. Now we need to look for our last what? Phi, our last phi, which is this. Now my phi 3 is equal to phi 3 of s is the same as integral from a to b, k of st, and then phi 2 of t dt. We need to find for our phi 2 of t. So let's change this x here to t. We're going to have phi 2 of t to be equal to t over 12. I have to substitute this phi 2 of t into this equation and our kernel, which is the st, into this equation. And the limit is what? 0 to what? 1. So we're going to have phi 3 of s to be equal to integral from 0 to 1 st dot t over 12 dt. So here becomes integral from 0 to 1 st squared divided by 12 dt. Now if you integrate t squared, we're going to have st raised to the power 3. Then this 3 times 12 will give you 36. Evaluate it from 0 to 1, which is the same as s over 36. This implies that our phi 3 of s is the same as s over 36. Now we need to look for our solution from this relation. So it says that the first 3 is successive approximation. So if I'm having y of 0 of s, which is the same as phi naught of s, and phi naught of s is given as s squared. Next one is phi 1 of s, which is the same as phi naught plus lambda phi 1 of s. And in the question, I said lambda was given to be minus 1. So and phi naught of s is given as s squared. So s squared, so minus 1. Yes, minus 1. So minus. And phi 1 of s. Phi 1 of s is the same as s over 4. So that's s over 4. Let's place that. Let's put that s over 4 here. We have s squared minus s over 4. Or the next solution, which is y2. Now y2 is given as y2 of s is the same as phi naught of s plus lambda phi 1 of s plus lambda squared phi 2 of s. Our lambda is given as minus 1. Phi naught is given as s squared. So here is equal to s squared minus s over 4. Phi 1 of s is given as s over 4. minus s over 4. So phi 2, which is lambda square. So this lambda square is the same as what? 1. So plus and phi 2 of s is giving us s over 12. So plus s over what? 12. And this can be written as, can bring the what? Minus what? S outside. So I'm going to have s squared minus s into bracket. What means here is what? 1 over 4. 1 over 4, then minus what? 1 over what? 12. Can we write this 12 as what? 4 times what? 3. So 4 dot 3. And then solution is y3. y3 of s is because they say 3 successive what? Approximate solution. So y3 of s is giving us phi naught of s plus lambda phi 1 of s plus lambda square phi 2 of s plus lambda cube phi 3 s. Our phi naught is the same as s squared minus what? This, which is the same as what? S over what? 4. Lambda square is 1. So phi naught of s is the same as 12. So plus s divided by 12. Then lambda cube minus 1. So minus phi cube is given as s over 36. So minus s over 36. This can be written as s squared minus s into bracket. So here becomes 1 over 4 minus 12. 12 is the same as 4 times 3. So 4 times 3. So here is plus 1 over 36. 1 over 36 is the same as 4 times 3 times 3, which is the same as 4 times what? 3 squared. So this is the 3 successive approximation solution for the what? For this integral equation. And so anytime you are given a question to solve, you see successive approximation of the solution. That means you are going to use what? The approximate method using the free term. So these are the three things you have to note. 1, 2, and 3. So these are the 3 key things you need to put in your head. So we move on and take our next example. In the next example, we are going to take under approximate methods. In this example, the example is a carefully solve the integral equation below. Y of s minus lambda integral from 0 to t s of t y of t dt, which is equal to f of s, where the investigated parameter, which is lambda, is equal to 1 over 2 and f of s is equal to what? 5 over 6x. Show clearly the resultant kernel and the radius of convergence. The keyword here is what? Resultant what? Kernel. So anytime you are given a question, they say the question is saying that solve for the resultant kernel. That means the question is trying to tell you that use the approximate method, and that's of using the kernel to solve for the resultant kernel. Now let's start. Solution. In our previous video, we said we were given some relation, 3 relation. That first, we need to look for our iterative kernels. We follow to look for the iterative kernel was given in the previous video as kn of st is equal to integral from what? A to what? B. K of what? The original kernel, k of s comma s, kn minus 1 st ds. And the next relation was what? The resultant, or the formula for the resultant kernel, which was given as gamma of st lambda, which was given as we are to sum all the what? The iterative kernels, including lambda. So we are going to get k1 of st plus the lambda k2 of what? St plus lambda n minus 1 k n of st. So you could easily see that this is the same as a summation of lambda n minus 1. Then k what? N of st. And n starts from 1 to infinity. And to get the solution for this integral equation, we said that the solution will come out when using the approximate method. Using that of the kernel, solution will come out as y of s to be equal to f of s plus lambda integral of what? A to b. Then the resultant kernel, gamma of s t lambda, then what? F of t dt. So these are the three relations we are going to use to solve for what? This integral equation. Now let's consider the integral equation in the question, which is giving us y of s minus lambda integral from 0 to what? 1 st y of t dt, which is equal to f of s. Now let's make this y of s the subject of the equation. I'm going to get y of s to be equal to f of s plus lambda integral from what? 0 to 1 st y of t dt. Now, from this relation, let's generate our first kernel, which is the k1. And in the previous video, we said that k1 is the same as our original kernel. So let's look for our original kernel from this integral equation. Our original kernel is given as st. K of st is equal to st. And we are saying that k1 is the same as our original kernel. This implies that k of st is equal to what? K1 of what? St, which is equal to what? This st. We proceed by finding our what? K1, 2. K2 of what? St, which will be equal to integral from what? A to what? B. Go from A to B. Then the original kernel, K of what? S. Then K what? 1 of what? St ds. From this first relation, n minus 1, we are having 2 here, it becomes what? K1. And we are having the original kernel to be kss. Now, in the original kernel, let's interchange the t's to s. We are going to have k of x comma s to be equal to s. And we said that k1 is this. And so let's change all the let's change all the s here to s. We're going to have our k1 of st to be equal to st. Now let's substitute these two equations to what? This equation. And integrating from what? 0 to 1. 0 to 1. And because of it's 0 to 1, because this is a Fredholm's what? Integral equation. Our k2 of st becomes integral from 0 to 1. Then k of what? S comma s. This is the same as what? S dot k1 of st is the same as st ds. Now if you multiply these two equations, I'm going to these two things are going to get integral from 0 to 1 st then s squared ds. Now if you integrate s squared, you're going to get what? S cubed then divided by what? 3. We're going to have here as we're going to have s cubed divided by 3 divided from what? 0 to what? 1. So I'm going to have our k2 of st is to equal to st over 3. Can still proceed by finding out k3 of what? St. And from our first relation, we are going to see that we are going to have integral from what? A to what? B. Ks of s. Then k2 S T ds. Since the relation is saying that if here is n, then here is what? N minus 1. And we are going to integrate from 0 to 1 because we are dealing with the Fredholm integral equation from 0 to 1. And our original kernel is what? K of what? S comma S, which is this. And we need to what? Interchange the what? The x to s in this K2 of st. So K2 of st will be the same as. So we need to change this s here to s. We're going to have st divided by 3. And you have to substitute these two equations into what? K3. I'm going to have our K3 of st to be equal to integral from what? 0 to what? 1. 0 to 1. Then our Ks of s is the same as what? S dot the kernel K2 of what? St, which is the same as what? St over what? 3. So St over 3 ds. If you multiply these two things, you're going to get integral from 0 to what? 1. Then this time you're going to have s squared. So st divided by 3. Then s squared ds. If you integrate s, you're going to have what? S cubed divided by what? 3. This same 3 times 3 will give me what? 9. So I'm going to have st divided by 9, s cubed evaluated from 0 to 1. I'm going to have this to be what? St over what? 9. Which means that our K3 of what? St is the same as what? St over what? 9. You can move on to what? Find for your what? Your K4, that of your K5. And then substitute it into what? The second, this relation, which is the what? The resultant kernel. Find kernel from the iterative kernels. Resultant kernel, gamma of st lambda. He said it's equal to what? K1 of st plus lambda K2 of st plus lambda square K3 of what? St plus dot dot dot. We had our K1 of st, which is the same as the original kernel, to be what? St. So let's substitute this st into that equation. So we're going to put the st at what? K1. We're going to have this to be equal to st plus our K2 of st was also giving us. We're able to solve it. We have K2 of st to be st divided by what? 3. So we need to put it into this equation. We're going to have st lambda divided by 3 plus our what? K3. Our K3 was also giving us what? St divided by what? 9 plus st divided by 9 lambda what? Square plus what? Dot dot dot. So if you study this series, you will see that it's a geometric progression. Since it's a geometric progression, you can easily find for what? The ratio of progression. The ratio of progression is giving us, which is given as this term divided by what? This. So st lambda divided by 3 divided by what? St, which is the same as st lambda divided by 3, then what? Times what? 1 over what? Your st. This st will cancel what? This st. Now our ratio of progression becomes R is equal to what? Lambda over what? 3. So from this, you can easily find for the sum of what? This GP, this geometric progression. And therefore gamma will be equal to gamma of st lambda will become the first term. So let's say a1 over what? 1 minus what? R. A1 is giving us what? This st. So let's substitute st here. divided by 1 minus what? The ratio. The ratio is given us as lambda over what? 3. We have lambda minus 1 minus what? Lambda over what? 3. So if you carefully solve this one, you can see that they is the same as 3st divided by 3 minus lambda. So our resultant kernel, gamma of st lambda, is the same as 3st divided by what? 3 minus what? Lambda. So this is our resultant kernel. So after getting our resultant kernel, we can and the question also went on to say that we should find for the radius of what? Convergence. And for the series to converge, in our period, it said for the series to converge, the ratio of convergence should be what? Less than what? 1. So R should be less than 1. R should be less than 1. So if R is less than 1, that means R is given as what? Lambda over what? 3. So you can find the absolute, right? Absolute of lambda divided by 3 is less than 1. That means absolute of lambda is what? Less than what? 3. So this is our radius of what? Convergence. Now we need to find the solution for the integral equation. We had our general solution to be equal to y of s to be equal, which is equal to f of s plus lambda integral from a to b and resultant kernel st lambda f of t dt. Now we know we have our resultant kernel, so let's place our resultant kernel into this equation. I'm going to have y of s to be equal to f of s plus lambda integral from what? We're integrating from what? 0 to what? 1. Because in the question we're giving the limit of integration to be 0 to 1. So it becomes 0 to 1. The kernel, resultant kernel is giving us 3st divided by 3 minus lambda. Minus lambda, then your f of t dt. Okay. In the same question, they gave us our investigative parameter to be equal to half. And the free term, f of s, to be equal to 5 over 6s. Now I need to substitute this two equations into this. Then we can find for what? The solution to the integral equation given in the question. Now we are having f of t here. Then let's change this s here to t. I'm going to have f of t to be equal to 5 over 6 t. Now let's substitute this things into this equation. I'm going to have y of s to be equal to f of s 5 over 6 s plus lambda integral from 0 to 1. The kernel, 3 of sc, 3 minus lambda. Then f of t is this one. So let's put it here. We have times what? 5 over 6 t dt. Y of s becomes this 5 over 6 s plus lambda. You can bring what? S over 3 minus lambda is a constant, and 5 over 6 is a constant because it's not what? It's not of t. You are integrating with respect to t. You can rewrite this as 3s lambda divided by what? 3 minus lambda times this 5 over 6 times the 5 over 6. Then integral from what? 0 to what? 1. T times t will give me what? T squared. with t. So this y of s becomes y of s to be equal to 5/6s. So our lambda is given in the question as what half. So plus 3s into bracket 1/2 divided by 3 minus what? 1/2. Then all times what? 5/6. So if we integrate this t square, we're going to get what? T cubed divided by what? 3. Which is evaluated at 0 to 1. So y of s becomes 5/6s, then plus, so here becomes what? The same as 3/2. 3 times what? Half, the same as 3/2. All divided by 3 minus half, the same as 5/2. All divided by 5/2. All times what? 5/6. So if you put 1 here, you're going to get what? 1/3. So times what? You get times 1/3. And there's what? S here. So s. So this is the same as 5/6s plus. So this is the same as 3/2s times what? 2/5 times 5/6 times what? 1/3. I'm going to get 5/6s. This 3, these 2 cancel these 2, and this 5 also cancel this 5. So we're going to have 5 cancel 5, 2 cancel 2. Now this 3 also cancel what? This 3. Now it will remain with what? 1/what? Plus 1/3 what? S. 1/6s rather. So if you add these things, you're going to get what? 5/6s plus 1/6s. You're going to get x, which means that the solution is what? S. So y of s is equal to s, the solution to the Fredholm's integral equation given in the question. So this is the end of this session.